so that our yu is 1 over 1 plus u squared sine v, meaning that a change of delta u from this point, a change in the u direction of delta u, or from any point, is going to be delta x in the I direction plus delta y j, and that's going to be, the delta x is going to be xu delta u, the rate of change of x with respect to u times delta u. So that's xu delta u I plus similar expression for the y, yu delta u j. Now evaluating these expressions at pi over 3, 1, v equal pi over 3, u equal 1, xu is 2 cosine v, which would be 2 times the cosine of pi over 3, and the cosine of pi over 3 is 1/2, so xu is just 1. And yu is 1 over 1 plus u squared times the sine of v. Well, let's see. The 1 over 1 plus u quantity squared is u equals 1, so that's 1 over 2 squared, 1/4. Sine of v is the square root of 3 over 2. So we have 1/4 square root of 3 over 2. That would be 1/8 the square root of 3. Square root of 3 over 8 times delta u j. So for delta u at the point pi over 3, 1, we get this vector, ultimately this, in x and y. So our xy vector for delta u at pi over 3, 1 is this, which is equal to this, which is just I plus the square root of 3 over 8j delta u. And that almost looks like a subscript on the delta u, so let's separate that, meaning that whatever delta u is over here, we're going to take I plus square root of 3 over 8j, that's approximately I plus 0.2j, and multiply that by delta u over here. So if delta u is this long, it's going to be just a little longer over here, and it's going to be in the direction of I plus 0.2j, 1 unit over here, about half a unit up here, and that'll be 1 unit of delta u and half a unit, 0.2 units of delta u in the y direction, and that's going to give us a vector that looks something like this. So this vector is I plus square root of 3 over 8j delta u. Now, calculating similarly with a little less explanation, xv is easily calculated. That's just negative 2u sine v, and yv is also easily calculated. It's going to be 1 over 1 plus u cosine v. Now evaluating these expressions, these functions, at the point v equals pi over 3, u equals 1, we get the vector delta xi plus delta yj looks just like the expression we had here, but in this case the delta x and delta y are being driven by change in v. So now this vector is going to equal xv delta v I plus yv delta v j. Now, as before, we can factor out a delta v the same way we factored out a delta u here, and I'm going to do that before I substitute my values for xv and yv. Well, actually, I'll write those values in. Okay, xv at pi over 3, 1. The sine of pi over 3 is the square root of 3 over 2. So this will be minus 2 times the square root of 3 over 2. And I think that's going to give us negative square root of 3, giving us negative square root of 3i. Remembering that we're going to write the delta v down at the end, having factored it out. And yv, 1 over 1 plus u is 1/2. The cosine of pi over 3 is 1/2, so that's going to be 1/4 j times delta v. Now delta v is just our displacement over here in the v direction. And that delta v multiplied by this vector, well, let's see, negative square root of 3 is about negative 1.7, well, it's negative 1.732, about negative 1.7i, and 1/4 about 0.25j. So you're going to have a pretty big negative I component, about 1.7 times as big as delta v, and a pretty small j component. Let's see now, if delta v is this long, 1.7 times that maybe be over to about here, and then we come up just a couple of tenths, and I probably exaggerated that y displacement, but right here then would be our vector, negative square root of 3i plus 1/4 j delta v. These two vectors form two of the boundaries, or correspond to two of the boundaries of our delta u by delta v region over here, provided delta u and delta v are small. The corresponding vectors along the top and right hand side of this region will be parallel more or less to these vectors. So we're going to get a parallelogram here, whose area is the cross product of these two vectors in the xy plane. Now let's give a general identification for these two vectors. This vector is nothing but xu du plus yu du, xu du I plus yu du j, which is just the derivative, partial derivative with respect to u of xi plus yj times du. Now if du is delta u, then evaluating this expression at this point, at this value of u and v, this point, gives us this expression. Similarly, this expression is just partial derivative with respect to u, with respect to v of xi plus yj times delta v. So if R equals x of u v I plus y of u v j, then this is r sub v, our derivative r sub v times delta v, and this is derivative r with respect to u times delta u. So our area increment becomes the area of the parallelogram divided by RV delta V and RU delta U. Area is magnitude of RV cross RU delta U delta V. Just the cross product of these two vectors.